color code, color code, color code. Like use highlighters as much as you possibly can. It will make a huge difference in what it'll isolate some of your problems, help you get past that stuck moment. So the first four are pretty just basic. The idea is that if it's inscribed, it is on the circle. The vertex is sitting.
Ooh, your screen's not showing.
It's not. Oh, shoot. Sorry. Thank you.
You're recording but not showing us the screen.
Yeah, I'm recording it. I guess I was waiting for you to see it later. Okay, so the idea is that if it's on the circle, then it's inscribed. And that matters because inscribed angle is 1/2 of the intercepted arc, which sounds like French, but just hold on to it because it's going to matter. But what I realized earlier is the arc is double the angle, was the questions I was getting earlier, because they were asking where'd the 1/2 come from our videos for today and things like that. So the idea is that if I had a number here, so we'll call this 70, then to work out, you double it for 140. But if I was given 140, I have to half it to get the 70. So working out, you double. To work in, you half. Number 2, this vertex is just floating around, so it's neither. The vertex either has to be sitting on the center or on the exterior of the circle to be able to know anything about its angles or its relationship to the inner arc as well. Jared, this is what we're working on. It's in the chat box if you want to print it. If not, you can just pay attention too. So this is a central angle. And the vocabulary is not like exactly what the word is. It's probably not like you don't have to be able to write it. But just know that if the vertex is on the center, then this arc measure, so if it was 40, then the angle is also 40. So they're kind of a gift. So it is the arc and the center angle are going to be the same measure always. So it's a 40-degree arc angle. It's a 40 degrees angle on the inside. So again, it's on the circle, not on the center. So that's inscribed, which means the angle is inside the circle, obviously. All right, so here's where it gets to be fun. The first two are pretty basic. There's just some extra fluff. So this angle is where my information is. It goes like this, so it goes to M and L. So that angle is going to tell me about the arc that is between those two ends of the lines, or vertexes of the triangle, if you want to think about it that way. So working out, you're going to double because we're working out. So 56 times 2, so it should be 112 degrees for that question mark angle. And then remember some other call-outs I talked about during tutoring to make sure you don't forget. A semicircle, so half a circle is 180. A full circle is 360. Because like in this case, I should know because K to M, this is a diameter, which means it splits it into 2 half circles or 2 semicircles. Then that angle MLK, so this angle right here, is going to be half of 90 or half of 180, so it's going to be 90 degrees. With that said, then I could obviously solve for the other one because we know the internal angles of a triangle are 180. So this is where they kind of start playing with you because they could put, especially this one, they could put the question mark anywhere because you, with that 56 and all the rules in math you should have in your brain somewhere, you should be able to solve all of them. So like 90 plus 56 gives me 146. We're going to subtract that from 80 or 180, and we get 34. So 34 would be this angle here.
A lot of colors.
If I work out, that's going to be 64 degrees for that arc. Or you could also, and there's different ways to think too. If you're an arc or an angle person, like I'm used to triangles. For some reason, that's what my brain sees first. If you know this is 180, and you know this is 112 and you feel confident, then you could subtract those two from 360 to get that 64 as well. Because all the arcs around the outside should equal 360. All the angles on the inside of the circle should equal 360. Angles inside a triangle are 180. All right. Number 6. So I'm starting on the outside and working in to this inscribed angle because it is on the circle. And Z to Y is where that 82 is. So since that I'm working in, I'm going to half. So 82 divided by 2, or times 1/2, it's going to be 41. So that's the question mark, would be 41 degrees. This one does not have enough information to do anything else because you don't have a semicircle. That's not a diameter. That's just a line. So that's the only thing they could ask you for from that drawing. So not quite as wide open as the last one. Now, number 7 always freaks everybody out. So here is your, it's just a lot of extra fluff. Again, so you want to look for what they gave you. So they gave me this arc, which is from here to here. I have a line that goes all the way back to this inscribed angle, and it comes out. So that is the inscribed arc, or intercepted arc with the inscribed angle. So we're going to work in, and if I work in, I'm going to half. So 70 divided by 2 gives me 35 degrees. So that question mark would be 35 degrees. And again, because you don't have, yeah, that's all you can do for that one too. Because there's not a semicircle or enough information to do anything else with it. So this is a quadrilateral, 4-sided figure. All 4 of these angles are going to equal 360. And that hopefully makes sense to you because here all the way around is 1/2 of the circle, and here all the way around, and I shouldn't say half, one portion of the circle, and this is the other part of the full 360. So these opposite ones are going to be half of 360 each. So that's how you get your 360 within the quadrilateral as well as with your circle. The question mark, I'm sorry, it says EDC. So it's a measure of arc EDC. So E to D to C. So I'm solving for this arc. If I trace these back, that gives me the angle P, or it's actually angle EPC. I'm working out, so I'm going to double that 107. Which gives me 214. Now, because I know that 214, because of the 107, and the way this one is laid out, you also could find the arc measure of this one, because 360 minus 214 would give me 146. So I know this entire arc is 146. And knowing that, I could work in to that angle and half it. So it'd be 73, yeah, 73 degrees. So working in half, working out double. Tracing your angles to figure out what they touch helps a little bit. Everybody kind of okay?
Miss Sigmund?
Yes, sir.
How many questions do you think will be like this on the EOC?
2 or 3.
No miss them.
2 or 3. But don't worry, the more you do them, the easier they get, I promise. It starts to make sense. Today's just the first day you've seen it.
Wait, can you go to the first problem real quick?
That one?
No, wait, is that the very first one that we did? Yeah, the 64 one. That one doesn't equal 360. So 64 and 112 don't add up to be a whole. It's like, again, yeah, I don't know. It's like,
Oh, no, it should be more. You're right. Okay, hold on. Where do we mess up? 56. 56 plus 90 equals 146 minus 180 is 34. 34 times 2. Oh, because it should be 68.
yeah.
For sure. Yeah, that's my bad math.
Oh, no.
Not using a calculator. I'm doing all the things I tell y'all not to do.
No, yeah, no. I was just confused. I was like,
68. And now we should be equal to 360. Yeah. Yep.
yeah, you
Yep. Good call out.
I'm still going to miss these problems.
No, we're just getting started.
So
Just
wait,
getting started.
So that one that you said that people trip up on was the number 7, and you just did 70 over 2 is equal to 35 degrees?
Yep. The reason people trip up is because there's all these extra lines, and you want to be able to do something with them, but it's irrelevant to the question.
Okay.
It's like a word problem, but not. It's a picture, if that makes
Oh,
sense.
okay.
Like, it's all that extra fluff. Like, just don't panic. Like, you look at it and you think, whoa, that looks crazy. But realistically, if I could to answer the question, you need none of that, or even that. And if I gave it to you like that, most people have no problem. It's when you start putting extra lines in there, it's the visual, like finding out, and which is why I say, for me, using like a color like that, like a pen or a marker, then it looks a little less mumbo jumbo-y, I guess is the right word.
Okay.
Because like this one, hopefully it's not after some practice, should not be too terrible. So they do want to know what this is. Be careful, because if it's a multiple choice question, which could be, they're going to give you all the like steps. So this is definitely like a multi-step style problem, because the only arc that I can solve for with the information given right now is that one that I just colored lime green. And we're going to work our way out. So we're going to double. So 96 times 2 is 192. But I now have this 45 over here. So 192 plus 45 is 237. And we know that a full circle is 360. So 360 minus 237 gives me 123. So then our question mark is 123. But if it had been a multiple choice question, my guess is they're going to have 192, they're going to have 96, they're going to have 45. They're going to have all the answers that you would pick, like your trickster answers, the ones where you get excited because you didn't finish the problem, but you got a number and you jumped too fast. But that one's fairly easy, I would say, like arguably for questions that they could possibly give you. Again, noticing that you see a diameter. So this is going all the way through the center. So I know this whole thing is equal to 180. They've given me 80 on the outside. So then I know that this little portion here is 100 degrees, because that's 180. Gives you the 180. Then I'm going to work in. And when I work in, you're going to half it. So half of 100 is 50 degrees. That one, those two hopefully are not too terrible, or at least you see where I got it from. The name of the game is going to be tons of practice and just remembering the circles and not getting caught up with all the other fun math we've learned. All right, so this one, we are looking for this guy, which means I need this arc measure to be able to work in to half to get it. I have 56 or 58 and 132 already used. So we're going to add those two together. Should be 190. And that's this portion. But I know that everything left over is out of that 360. And that's going to give me 170. So 170 is the arc out here. And then to work our way in, we have to half. So 170 divided by 2 gives me 85. So our question mark is equal to 85 degrees. All right, number 12.
So with the 33 on here, you double it, right?
Double it to go out, because you're working out, because you're working towards your arcs. So that's going to be 66 degrees out here. But again, if it was a multiple choice question, that answer is going to be there. That's not the question. That's just the math that's necessary. Right, we got to go find the question mark. And so since I used 165 and I used 66.
Add them in, subtract with the 60.
Yep. So 165 plus 66.
231.
Yep. Then from 360.
129. Okay.
This arc is now 129. And just to make it more fun, so if they had this, we'll call it F.
So is that all you do?
That's it.
That's all you do?
That's it. It's literally, like I said, it's one of those things that is not normal because you haven't done it a lot in previous math classes. But once you do enough of them and take a deep breath, like, they're repetitive. I will say they're going to get algebraic, which I have at the bottom, but it's the same thing. But the biggest thing, like I always say, is that you just have to do that many of them. And then you're like, oh, that's ridiculous. That's super easy.
I also got to ask.
Mm-hmm.
I wasn't paying attention close enough.
Mm-hmm.
How did you get the 66?
33 doubled.
So do you always double that number?
If you're going out to the arc. If, like, I was given the 66 and I'm going in, I mean, think about going in and out is opposite, right? So if I'm working out, I double. If I work in, the opposite of doubling would be half.
Huh.
Yep.
So say you were going out and it was 66, so it would be 33. Would you add the 165 to 33?
Okay, hold on. I think you're saying no, because you would still add it to 66 because we're adding the outside to get the outside. So it's angle versus arc. So if you're working towards arc, you double. If you're working towards angle, you half. Out here, the question is about an arc.
Okay.
Yep.
So, but do you always add on the first part, like on the left side where it says 165 plus 66? And if you're going in or out, do you always add?
What do you mean by that?
I think I know what he means. Like, but every question, I don't want to give you a hard answer because there's not a hard yes or no. We could say vaguely yes, because you have to add them together to then subtract from 360 to find the missing arc. If you are looking for a missing arc, you are going to add together whatever's been used to then subtract from 360. And the reason I can't say yes is because theoretically, depending on how your brain works, you could have taken 360 and worked it like 360 and then just gone minus 66, got an answer, minus 165, got an answer, and then that would be your answer. So hard yes on addition is not possible, but it could be a rule that you make for yourself.
Cool. That pretty much solved it. Thank you.
Okay, yeah. Perfect. Absolutely. All right, so here's where we're getting to more like what you're probably going to see for EOC style questions. Because, of course, our EOC style questions, they only have 60, and they're making sure you've learned all the math. Still the same process, though. So I have an angle. This is an inscribed angle. I'm going to work my way out. And the reason I know I got to work my way out is because here's where my variable is. So I know I'm dealing with arcs. So I need to have as many of the arcs filled in as possible. And so 44 working out, am I going to double or half?
Double.
Yep. So working out, you're multiplying by 2 or double. So that's going to be 88.
Mm-hmm.
So now I have 131, I have 88, and then I have 18x minus 3. And all three of these are going to equal up to how much? 360, right? Because it's a full circle. So you could do it, if you want to do it like algebraically, like teacher-wise, you would do 131 plus 88 plus 18x minus 3 equals 360. Most students, usually take the 131 and 88, add them together, which is the same thing you would do algebraically.
Mm-hmm. To get 219 plus 18, okay.
And then subtract that from the 360. And you're just solving an equation at this point, 141. Because I know this section, so like if we were doing like the previous ones, we know that section is going to equal 141. Which in our previous examples, that would have been the end of it. That's what it was asking for. But at this point, we're trying to look for x. So then you could pick up here, because most of you don't like writing equations like this. So now we're going to add 3 to both sides. So 18x equals 144. Divide by 18.
8.
Yep. X equals 8. You're done.
So they're still making you solve for x in these type of equations?
Yeah.
Wow.
Is x as far as they'll go, or will they also have like a y in there?
With that illustration, like this example, x could be as far as, it's got to be all they got. There's not enough markings. If it did like this, so here to here, they could put a y like right there, maybe.
Yeah, okay.
Most of the ones I think that I can remember, it's really you're just solving for one thing. They give you multiple questions instead of solving for multiple things in one circle. like EOC wise. But even if you had a Y right there, I mean, that's hopefully after a couple more practice problems, fairly easy. You're just working in, and when you work in, you half it. So that's 70.5. Right? Yeah, 70.5.
Ms. Sigmund?
Yes, sir.
So you said the EOC questions were not exactly like this, but similar?
Yeah. Because, and I mean, obviously we're always guessing because they only give us so many to practice or to look at or let us see and that kind of stuff. And of course, as soon as you get real comfortable with it, they give you something totally different. But always an EOC or a state given test is trying to test multiple math skills within one question. So the ones prior, you're really just testing the basics. Like, do you know this rule? That's it. And it's not that they won't give you one of those. They could. But I always like to prepare for, like in this case, you had to know that a circles were a 360. You had to know how to double to work your way out. And then you had to know how to solve for X. So, like, it's a multi-part question. Very rarely are EOC questions just like, boop, I need an answer, and I'm out. There's usually steps. Like, you have to be able to show that you can do more math. Like, even, I mean, obviously that equation is a math 1 level, probably even arguably 8th grade math level solving of an equation. And they talk about that your skills that are needed to pass your EOC are the 1, 2, 3. Like, all of it's fair game. Which, like that circle question we had, and it said, find the area of the shaded region that was on our practice EOC questions back a couple weeks ago. Like, Miss Kordek even laughed. She's like, we just did that in 6th grade. So it's just, they're testing all your skills, if that makes sense, in a 4-hour-long test. So they're going to have to double up on some things. So this one is similar, but slightly different. I'm looking for my angle, this arc, which means I'm going to have to work my way in. And when I work my way in, do I half or double?
Half.
Half. Work in, you half. Work out, you double. So working in. So that means I need this number. I need my arc measure here. I have 58 and I have 140. So I can add those together. That's a total of 198. The whole circle is 360. So we're going to subtract the 198. Which gives us 162. Which goes right here. Then when I work in, would you tell me I'm going to do again?
Half.
I'm going to half it. So half of 162 is 81. So 6x plus 3 is equal to 81. And then now we have to solve it. So subtract 3 from both sides, which gives us 78. Divide by 6. X equals 13.
13. Yes.
So the answer is going to be 13 they're looking for. Again, prepare yourself, though. If you don't slow down and reread the question, 162 would be there if it's multiple choice, 81 is going to be there if it's multiple choice, and 13 is going to be there if it's multiple choice. Because they're trying to catch you when you get excited, if that makes sense. Like, you think you're doing exactly what you're supposed to do, and you just jump in the deep end with no swimming. Like, you just don't finish the thought process. So number 15 is a great one as well. So that 5x minus 7 is my L, so it's in here. They just can't squeeze it in there for whatever reason. And 57 degrees. So as soon as you see a diameter, which means it connects outer to outer and goes through the center, which is here, that means I know this whole side is equal to how much?
180.
Yep. Because it's half of a circle, right? A diameter just cuts the circle into 2 equal parts. This diameter here. So I can't do anything with this yet. I need to use my 57 and work this way. What do I do when I work out?
Double.
Yep. So 57 times 2 is going to give me 114. And that's from L to K. This is 114. So if I know the whole half is 180, subtract the 114 lets me know that I have all the same color pins right in front of me. That's weird. So this is 66 because 114 plus 66 gives me the full 180. And then I'm going to work into my 5x plus minus 7, 5x minus 7. So what is the measure of the entire angle if the external arc is 66?
33.
Yes. So 5x minus 7 is equal to 33. So I'm going to add 7. 5x equals 40. Divide by 5. X equals 8.
Where we get 33 from?
66 working in, I'm going to half it.
Oh, okay.
Yep. This one is kind of wicked, but realistically not if you know your rules. It's like a two-step equation or a multi-step equation back end of Math 1 when you start practicing these a lot. But again, still very, if you know your rules, should not be too difficult. So working in or out, you can choose because they're both given. Personally, I wouldn't half things because those numbers are odd, like 5 and 13, which means you're going to start dealing with decimals. But I could double anything, and the numbers are just going to get bigger, right? So if I take this guy, I have to double it to be able to work my way out, right?
Yes, can we get
Anybody. So my angle, so this is my angle. This is my arc. So to get from angle to arc, I double the angle. Otherwise, you would half the arc. And like I said, 13, if you half it, is 6.5, which is not terrible, but it's still a decimal. And there's just no need to deal with decimals and start making mistakes there. So 2 times 5 is going to be 10x plus 16, because 2 times 8 equals 13x minus 2, and then you just solve. So that is just making sure that you can decide which one to double versus which one to half. Now, had you halved 13x minus 2, as long as you did it correctly, it should still work. So minus 10x, 16 equals 3x minus 2. Add 2 because it's the inverse of subtraction. 18 equals 3x. We'll divide by 3. X equals 6.
Holy, so real, you lost me right there.
On the double and versus the half in part?
No, with like the 18, like, wait, what you do with that too? Like
I added it to both sides. Oh, this said I multiplied it 3. That's where I got the 10x plus 16.
Yeah, I'm saying, where did you get that from though?
Because the 5x plus 8 is the measure of the angle, and to work out to make them equal to each other, I double when I'm working out. So I multiplied it by 2 because then that would make it equal to the arc.
Okay.
Then just
now, when you were saying something about halving the arc, what you mean by that?
so you can work the same problem. Let's see if I can work it. If I have enough space. So 5x plus 8 equals 13x minus 2. Should work. The difference is this one just means I'm working in. Half of the arc is equal to the angle. So then you would have 5x plus 8 equals 6.5x minus 1. So if I add 1 over, that's going to be 9. Subtract 5x, it's going to be 1.5x. Then you divide by 1.5. Divide by 1.5. 9 divided by 1.5. Whoa, that's not right. Is 6 as well.
Okay, I prefer the other way.
Right. I mean, most of us don't want to deal with 1.5. You do have a calculator, so it's not the end of the world, but it's still a decimal.
Right.
And most of us don't like decimals and fractions, preferably, unless we're talking about money. So, and nobody associates this with money. Just to do one more of that same kind, and then we'll take a break from this for the day, so your head doesn't explode, because we are getting harder. Like, these are like tomorrow's style problems. The first 2/3 of what we just did was like today's level. Everybody at tutoring said that they stayed kind of like the first half or first 2/3 of what I've done so far in Delta. And most everybody also said the video was more confusing than the Delta. So reiterating, if you can do the Delta without cheating, then you're fine. Don't panic, just misunderstanding the video, if that makes sense. So this is the angle measure, 2x plus 35. This is the arc measure that it intercepts. So 2x plus 35, we have to manipulate these to make them equal to each other, because they're not equal to each other, right? The angle is half of the arc, or the arc is double the angle. I like doubling because, again, multiplying by 2, even if the numbers get kind of large, in my brain makes a lot of sense. So I just take the angle and double it. These numbers would be fine if I halved them. So again, so you're doubling the angle to equal the arc, or you're halving the arc to equal the angle is the y, or what we're doing. So then 4x plus 70 equals 2x plus 70. It's going to give me 2x equals 0. So x equals 0. Now, in this case, that's not what they asked for. They asked for the measure of CED. So 2 times 0 plus 35 equals 35. So the answer would be 35 to that question. If it was in the previous section, it would have been 0 because that's the value of x. But like I said, don't panic.